Hello everyone. Today we'll discuss about the RL series circuit. So in last videos we have seen pure resistance, pure inductance, pure capacitance. Okay, those were the individual circuits. So we had dealt with individual resistance, inductance and capacitance. But in this we need to deal with the combination of resistance as well as the inductance. So in the circuit, if you observe, there will be two. One is resistance and one is inductance is connected. Okay. So the voltage across the resistance is VR and the voltage across the inductance is VL, and current I is flowing through those. Consider an AC circuit with the resistance R and inductance L connected in series. Okay, so the input will be V is equal to Vm sin omega t. So this input is similar to the last videos. If you see, for pure resistance, pure inductance and pure capacitance, this input remains same. So for here also, for RL series circuit, the input remains same. That is V is equal to Vm sin omega t. The current flowing in the circuit is L. So voltage across the resistance is VR and the voltage across the inductance is VL. So VR is equal to IR is in phase. So how the VR is in phase, if you want to know, you can watch the previous videos about the pure resistance and pure inductance. Okay, so resistance will be always in phase and the inductance, if it is a second one inductance, it leads current by 90 degree. Okay, so using these two conditions we can draw the phasor diagram. If you see that the resistance VR, it's in phase, so that's why it's starting with the origin with a straight line. Okay, and if you see the inductance, it's going to lead by 90 degree with the angle of phi. So this is the difference of resistance and inductance. Like resistance means it's in phase and the inductance means it leads by 90 degree. Okay, so in graph you can observe that it's having the phase difference of phi. Okay, so input will be V is equal to M sin omega t and I am sin omega t minus phi, because it's going to lead by 90 degree. So here in graph they have given, instead of 90 they have given phi, so we'll take omega t minus phi. Okay, now we'll from the phasor diagram expression we'll find the reluctance voltage V and the angle phi. Okay, so to find the reluctance voltage, we'll combine these two, like resistance and the inductance. So V is equal to square root of VR square plus VL square. So VR input we know, that is IR, and VL input we know, that is I into XL. So substitute that in above equation. So you'll get V is equal to square root of IR square plus IXL whole square. Okay, so current is common, so I'll take it outside. So V is equal to I into square root of R square plus XL square. So these two, square root of R square plus XL square, can be taken it as impedance, that is V is equal to I into Z, where Z is square root of R square plus XL whole square. Okay, so to find the phase angle, phi is equal to tan inverse of the inductance divided by the resistance. Okay, so put the input like VL is equal to XL and VR is equal to IR. Okay, so I get cancels, so I'll get phi is equal to tan inverse of XL divided by R. So XL can be written as omega into L. So this also you can see in previous video, that is pure inductance, how we can write instead of XL to omega L. Okay. So the final expression is phi is equal to tan inverse of omega L divided by R. So now we'll find the instantaneous power. So to find the instantaneous power, we have the formula P is equal to V into I. Okay. So V we know, that is Vm sin omega t, and I we know, that is Im sin omega t minus phi. So this is the formula sin A into sin B. So simplify this equation. So I'll get P is equal to Vm Im divided by 2 into cos phi minus Vm Im divided by 2 into cos of 2 omega t minus phi. So this is about instantaneous power. So now we'll find about the average power. So to find the average power, we need to integrate instantaneous power with respect to one cycle. So P is equal to 1 divided by 2 pi, 0 to 2 pi limits. So Vm Im divided by 2 into cos phi minus Vm Im divided by 2 into cos 2 omega t minus phi into d omega t. So apply the limits for the condition of Vm Im divided by 2 into cos phi and the condition for Vm Im divided by 2 into cos 2 omega t minus phi. So second terms, it becomes 0. So remaining will be P is equal to Vm Im divided by 2 into cos phi. So 1 by 2 can be written as Vm by root 2 into Im by root 2 into cos phi. Okay. So V is nothing but Vm divided by root 2 and I is nothing but Im divided by root 2 into cos phi. So your average power becomes P is equal to Vi into cos phi. So draw the waveform according to the equation, like first one, that is V remains constant, that is Vm sin omega t, start with the origin, but you have to draw the current by leading 90 degree, and the power is going to flow through the positive as well as the negative. Okay, thank you.